Okay, now we're in section 3.2, which is on the product rule and the quotient rule. So, an important question is, how does differentiation behave under multiplication? We've seen that it behaves nicely with respect to constant multiples and with respect to addition and subtraction. Basically, differentiation acts the way that we expect it to. However, with respect to multiplication, what happens? What happens when I take the derivative of a product of functions? One is tempted to guess that the derivative of a product of functions is the product of the derivatives. The derivative of f times g is f prime times g prime. Is that right? Well, let's look. Here's an example. I'm going to take the derivative of x plus 1 times x plus 2. Our guess is that this is the derivative of x plus 1 times the derivative of x plus 2. The derivative of x plus 1 is, well, the derivative of x is 1. The derivative of 1, which is a constant, is 0. The derivative of x plus 2, for the same reason, is 1 plus 0. 1 plus 0 times 1 plus 0 is 1. Let's think about what the derivative means. It is the slope of the function. This is saying that the slope of this function is constantly equal to 1. There is only one sort of function which is going to have a constant slope, a linear function, something equal to mx plus b. This is not a linear function. This is a product of two linear functions. This is a quadratic function. It should not have a constant slope. So this cannot be correct. Just because I cannot leave such awful mathematics on the board, I have to do it the right way. So this is the right way that I would take the derivative of x plus 1 times x plus 2. It's a polynomial. It's a product of two polynomials. I can multiply it out. X plus 1 times x plus 2 boils out to x squared plus 3x plus 2. And we saw last section that this is something that I can take the derivative of. The power rule says the derivative of x squared is 2x. The derivative of 3x is 3 times the derivative of x, which is 1, so just 3. The derivative of 2 is 0. Great. So if I have a product of polynomials, I can multiply it out and then take the derivative. But what do I do if I have the product of two things that I can't multiply out? Well, we need a rule, and that's going to be the product rule. So I would actually like to derive the product rule for you, but to do so, the best way to do so, I think, is to introduce some notation. This is not the way that we've been writing our derivation of derivatives, but this is going to be a useful way for the product rule, and also generally it's a useful way to think about derivatives. So if y is a variable that's related to x by some function f, and I'm going to let delta x represent a change in x, typically a small little change in x. You can think of that as the same thing as the quantity h in our typical definition of a derivative. Then I'm going to let delta y be the change in y. Specifically, it is f of x plus delta x minus f of x. When I change x to x plus delta x, how does y change? It changes by delta y. Then y prime, the derivative of y, is equal to the change in y over the change in x as the change in x goes to 0. It is the limit as delta x goes to 0 of delta y over delta x. I would also like to note that the limit as delta x goes to 0 of delta y is going to be 0 if we assume that the function is differentiable, because if it's differentiable, then it's continuous. So that means that f of x plus delta x will approach f of x as delta x approaches 0. Okay, so let's let u and v be variables. U is going to be in blue, v is going to be in red. They're depending upon x, which I'm writing in green. Well, if I change x by delta x, let's see how u times v changes. Well, what is the change in uv? What is delta uv? When I change u by delta x, it becomes u delta plus delta u. V becomes v plus delta v. And so uv becomes u plus delta u times v plus delta v. The change, therefore, is this times this minus uv. I'm going to multiply this out. I get uv plus delta uv plus u delta v plus delta u delta v minus uv. My two uv's cancel out, leaving me with delta uv plus u delta v plus delta u delta v. What we've sort of been missing in our discussion so far are these two pieces. When I change x by delta x, uv changes by the change in u times however big v was, plus u times however big u was times the change in v, plus the change of the two guys. Now this is what we've sort of been assuming is going to pop out, u prime times v prime. But it turns out that this piece actually doesn't matter. This piece is just going to go away, and it's going to be these two pieces right here that do matter. So I'm going to divide by delta x now, and I'm going to put the delta x under delta u in the first term, under delta v in the second term, and in the third term it doesn't really matter, so I'll just put it under the delta u. As delta x goes to 0, delta uv over delta x is by definition d dx of uv. Well, what happens over here? Delta u delta x goes to u prime, and v is just a v. U is just u, and delta v over delta x goes to v prime. Delta u over delta x goes to u prime, but since delta x is going to 0, delta v will also go to 0. So this actually goes to u prime times 0. This piece right here actually doesn't matter. It's these two pieces. At the end of the day, what I'm left with is u prime times v plus u v prime. And that is the product rule. Now using function notation, and this is typically the way that I will write the product rule, the product rule says the derivative with respect to x of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. So I just take the derivative of f, leave g alone, then I add, leaving f alone, and taking the derivative of g. Okay. So going back to this first example, let's apply the product rule to x plus 1 times x plus 2 and taking the derivative. Generally, I will suggest to just multiply this out and take the derivative, but let's just see what happens. So x plus 1 is f, x plus 2 is g, so when I take the derivative, I get f prime, which is 1 plus 0, times g, which is x plus 2, plus f, which is still x plus 1, times g prime, which is 1 plus 0. That's just 1, that's just 1. I multiply and I get x plus 2 plus x plus 1, which adds up to 2x plus 3. And that checks out with what it should be. Cool. Alright, so now let's just do a lot of examples. Let's let y be the square root of x times sine of x. Let's find dy dx. First, whenever I see a root, I'm going to rewrite it as a power of x. So the square root of x is x to the 1/2. And y is equal to x to the 1/2 times sine of x. Now I will apply the product rule with f of x equal to x to the 1/2 and g of x equal to sine of x. Well, then dy dx is f prime g plus fg prime. F prime is 1/2 x to the minus 1/2. That's just applying the power rule. I bring the power down and reduce by 1 times g, which is sine of x, plus x to the 1/2 is f, times the derivative of g, which is the derivative of sine, which is cosine. So I just have 1/2 x to the minus 1/2 sine of x plus x to the 1/2 cosine of x. If you want to make it a little more pretty, you can write sine of x over 2 root x plus root x cosine of x. Great. Okay, now let's let f of x be x cubed minus 2x plus 1 quantity times e to the x. Let's find f prime of x. I'm going to apply the product rule with, well, since I'm already using f to be the function, why don't I use the variables u and v to represent the two pieces of this product? U will be x cubed minus 2x plus 1, and v is e to the x. So then f prime is u prime v plus u v prime. The derivative of x cubed minus 2x plus 1 is, well, the power rule says x cubed has derivative 3x squared, minus 2x has derivative negative 2, and 1 has derivative 0, so that's done. I leave v alone, get e to the x. And then I leave u alone, I get x cubed minus 2x plus 1, and I multiply by the derivative of v. Well, v is e to the x. The derivative of e to the x is e to the x. It doesn't change, so I write that. This is good enough for me, although if you would like to, you can combine and write this as x cubed plus 3x squared minus 2x minus 1 times e to the x. Now let's let y be e to the t times cosine of t. Let's find y double prime. So that means we're going to take two derivatives. Well, we take the first derivative. This time, I'm not going to hold your hand as much. The product rule says take the derivative of the first guy, e to the t, which is e to the t, multiply against the second guy. Then I add the first guy, e to the t times the derivative of the second guy. The derivative of cosine is negative sine. So I'm left with e to the t cosine minus e to the t sine of t. To get the second derivative, I take the derivative again. Well, I like to use work that I've already done to make my life easier in the future. So here to take the derivative of y prime, the first thing I'm taking the derivative of is e to the t cosine of t. That was the original function. So I'm not even going to work. The derivative of e to the t cosine of t, I just figured out, is e to the t cosine t, e to the t sine t. So I'm just going to write that here. Then I subtract the derivative of e to the t sine t. So I get minus derivative of the first guy is e to the t, second guy is sine, I leave it alone, plus the first guy left alone is e to the t times the derivative of sine is cosine. I subtract the whole quantity, and that's my answer. However, I can simplify it pretty well. E to the t cosine t minus e to the t cosine t goes away, and I'm left with negative e to the t sine of t minus e to the t sine of t, which is negative 2 e to the t sine of t. You don't have to simplify your answers for me. However, if I ask you to take a third derivative here, you really kind of wish that you did simplify it at this point. So here is question 1. Let's let f of x be x times e to the x. Well, this has two parts. A, I would like you to compute f prime of x, f double prime of x, and f triple prime of x. B, if you see a pattern amongst these first three guys, I would like you to suggest a formula for the nth derivative of x. And if you can suggest a formula, can you actually prove your formula? Now, the power rule actually extends to arbitrary products of functions, by which I mean products of 3 functions, 4 functions, etc. Let me just talk about what happens with 3 functions. We rarely, if ever, will deal with 4 or more functions, but you can guess what the rule is after seeing this. So when I take the derivative of f times g times h, I get 3 terms, one for each factor of the function. And each time I take the derivative of just one of the functions and I leave the other 2 alone. So the derivative of fgh is f prime gh plus fg prime h plus fgh prime. Took the derivative of just f, then just g, then just h. So let's take the derivative of x squared sine of x e to the x. I get 3 terms. The first time I just take the derivative of x squared and leave the other 2 alone. I get 2x sine of x e to the x. Then I add what happens when I just take the derivative of the second guy and leave the other 2 alone. I get x squared plus the derivative of sine is cosine times e to the x. Then I add a third term where I take the derivative of the third guy and leave the other 2 alone. So I get plus x squared times sine of x times the derivative of e to the x, which is e to the x. That is the derivative. For more terms, you just keep adding more and more terms, taking the derivative of one function